Hi, it's been approximately 6 hours since I've recorded 5.1, just trying to upload those onto Neo. So in the meantime, I thought I would record 5.2, just did that with the microphone off. So let's give oh, is that working? Okay, let's give this another shot. Today is actually, or today, or whenever you're doing this, 5.2 is very similar to 5.1, except for the fact that you're going to use a random variable to then find a z-score, then to find the area. So instead of just given the z-scores like you were in 5.1, we're actually going to calculate those, okay? So our steps for today are to state the problem in terms of the random variable, or just know what we need to do, essentially. Standardize the values from step 1. In other words, find the z-score. If you remember from previous classes, the z-score is your random variable minus the mean divided by the standard deviation. And then you're going to interpret the results, essentially going from the z-score to an area using Table 4. Table 4 is just the z-chart, okay? That is posted in resources for you. And just remember when you're using that table, they give you the area to the left of the z-score. I'm going to be using the table, and then I'm also going to be using the TI Nspire. But let's do the table first for this example problem. Okay. Oops, not this page, sorry. This example problem. Suppose the distribution of diameters of a wheel produced at a local bicycle factory is normal with a mean of 17.4 and a standard deviation of 0.18. What's the probability a random wheel has a diameter between 16.75 and 17.25? I'm going to just go ahead down here and make some space for me to do number 1. Well, in order to do number 1, we need to first calculate the z-score of 16.75 and 17.25. So let's first do 16.75. The z-score, I'm going to write the formula up here again, is your random variable minus the mean divided by the standard deviation. So the z-score of 16.75 would be 16.75 minus the mean is 17.04 divided by the standard deviation is 0.18. And we get that that is a z-score of negative 1.61. Next, let's find the z-score of 17.25. So we'll say that the z-score is 17.25 minus the mean of 17.04 divided by the standard deviation of 0.18. That z-score is 1.17. Now, if you remember from 5.1, to find the area in between these two, we're going to look at our chart, and that gives us the area to the left of both of these z-scores, and then we're going to subtract the z-scores. Let me get a z-score chart. Okay, so let's first go to the negative side of your z-score chart. I'm looking for negative 1.61, which looks like that is going to be 0.05370. That's the area to the left of this z-score. Now I'm going to switch it to the positive side of your z-score chart to find the area to the left of 1.17. All right. 1.1 is here, and then let's go to the 0.7, and we get the area to the left of 1.17 is 0.87900. 0.87900. Now remember, to find the probability that it's in between both of these values, you simply subtract. So we're going to do 0.87900 minus 0.05370. We're always going to subtract the tinier number from the bigger number, but because we can never have a negative probability. So when we do this, we get 0.8253. So the answer to number 1 is 0.8253, or 82.53% of the data fall between 16.75 and 17.25. Now let's do number 2. We want to find the probability that the wheel diameter is greater than 17.5. Well, our first step is to convert that 17.5 into a z-score. So z equals 17, oh, it's not 25, sorry, 17.5, so 17.5 minus 17.04 divided by 0.18. We get the z-score of 2.56. Okay, well, we want it greater than 2.56. So let's say 2.56 is here. We're looking for this area. Please remember that your chart, though, gives you the area to the left. So let's look at 2.56 on our chart. 2.5 is here, 2.56 is here, 0.99477. The area here is 0.99477, but they wanted this area. Well, how would I get this area? Well, we know that the density curve, everything underneath the density curve adds up to 1. So we're simply going to do 1 minus 0.99477 to get 0.00523. So the answer to number 2 would be 0.00523, or 0.52%. Very tiny. I'm going to take a sip of water and come back and do all of this with the calculator. Okay, I hope I'm recording. I updated my iPad. I've done everything today, but it just doesn't seem to be working. I want to let you know you can do these problems without a z-score chart. You can do them with your TI Nspire. All right. So, and you can actually do them 2 different ways with your TI Nspire, but you're going to use that same command that you did in 5.1, where you go to Menu, Probability, Distributions, Normal CDF, because we are in a standard normal curve when we convert these random variables to z-scores. I went ahead and wrote the z-scores that we've already found here for all of our 3 random variables. If you want to use your z-scores, you can use this command, right? This command will always ask 4 questions. What is your lower bound, upper bound, mu, and your sigma? Well, in this case, if we want it between both of these, our lower bound would be negative 1.61. Our upper bound would be 1.17. And then because these are already standardized, our mu is simply 0 and our sigma is 1. So if I were to do this on the calculator, all right, I would go to Menu, Probability, Distributions, Normal CDF, put in my lower bound as negative 1.61, my upper bound as 1.17, and then we're going to leave mu 0 and sigma 1 and press OK. When we do that, we get 0.8253. That is exactly what we got when we did it with our chart, or 82.53%. I want to let you know you can also do this another way. If you didn't already have these z-scores and you had this problem, you could actually use these two values as your lower and upper bounds. So because we want it between these two random variables, we could use 16.75 as the lower bound, 17.25 as the upper bound, but here is not going to be 0 and 1 anymore because we didn't standardize these. So mu, we are going to put in 17.04 from the problem, and the standard deviation will be 0.18. We're going to get something very close to this. If we don't get the exact same thing, it's because we rounded the z-scores. So this is actually the most accurate answer, but I'm not concerned about that. I don't care which way you do it. So I'm going to go to menu, probability, distributions, normal CDF. My lower bound is 16.75. Upper bound 17.25. I've got to change the mean to 17.04 and the standard deviation to 0.18. And delete, 0.18, and then I press OK, and we get something very similar. We get 0.82475 or 82.4, let's round this up, 8%. These are very similar, and I would accept either one. This happens to be the more accurate answer because we rounded our z-scores here. All right, let's go on to the very last one, number 2. We've done it before, but we now want to do it with our calculator. This is the way you did it in 5.1, and you can always do it this way with z-scores. This wants you to find something that is greater than 2.56. So 2.56 would actually be your lower bound, and your upper bound would be a very big number. Let's just call it 999,999. I like to write 6 nines. Mu, because we already standardized this, is 0, and sigma is 1. When we do this on the calculator, we go to menu, probability, distributions, normal CDF. Normal and Z essentially mean the same thing. The lower bound will be 2.56, upper bound 999,999, and our mu remains 0, sigma remains 1. We press OK and get 0.005234, which is exactly what we got using our chart. All right, now let's not use the 2.56, and let's just use the information we had in the problem. Well, we want it greater than 17.5. So 17.5 would be our lower bound. Our upper bound would just be a big number. Again, let's call it 999,999. Well, because we didn't standardize the 17.5, we actually need to put the mu and the sigma in from the problem. Mu is 17.04. Sigma, or the standard deviation, is 0.18. Let's put that into our calculator. We should get something very similar to this. Menu, probability, distributions, normal CDF. Lower bound is 17.5. Upper bound 999,999. Mu is going to be 17.04. Sigma is 0.18. Press OK. Yes, we get something very similar, 0.005301. Both of these answers are very acceptable, and the answers also, if you were just to use your z-score chart, are also acceptable. Please say a little prayer that I can record this and, or not record it, upload it online, and then also that this was actually recorded. All right, thank you.